Series 28, Episode 82, for broadcast 9th of July 2025. Coming up on Space Time, the largest Oort cloud comet ever observed. NASA's Mars Perseverance rover sets a new distance record on the red planet, and the discovery of planets that can trigger stellar flares. All that and more coming up on Space Time.
Welcome to Space Time with Stuart Gary.
Astronomers have made a groundbreaking discovery by detecting molecular activity in the comet C-2014 UN-271 Bernardinelli-Bernstein, the largest and one of the most distantly active comets ever observed originating from the Oort cloud. The findings, reported in the Astrophysical Journal Letters, are based on observations from ALMA, the Atacama Large Millimeter Submillimeter Array Radio Telescope in Chile. The Oort cloud is a hypothetical sphere or region of frozen worlds, comets and icy debris caught up in the sun's gravitational field out beyond the solar system. It occupies a region of interstellar space stretching more than a light year from the sun, and it includes debris floating around in interstellar space as well as celestial bodies torn away from other star systems by the sun's gravitational pull. Astronomers studied this giant comet while it was still more than halfway to Neptune, at an astonishing distance of 16.6 times the distance between the Sun and the Earth. Comet Bernardinelli-Bernstein is a true behemoth. It measures nearly 140 kilometers across. That's more than 10 times the size of most known comets, and it's a fascinating celestial object to study. See, until now, little was known about how such cold, distant objects behave. The new observations have revealed complex and evolving jets of carbon monoxide gas erupting from the comet's nucleus, providing the first direct evidence of what drives its activity so far from the Sun. The study's lead author, Nathan Roth from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says these measurements are giving scientists a close look at how this enormous icy world works. Astronomers are seeing explosive outgassing patterns, which are raising new questions about exactly how this comet will evolve as it continues its journey towards the inner solar system. ALMA observed Comet Bernardinelli-Bernstein by capturing light from carbon monoxide emissions in its atmosphere and thermal emissions when the comet was still a long way from the Sun. ALMA's high sensitivity and resolution allowed scientists to focus on the extremely faint signal from such a cold, distant object. Building on previous ALMA observations, which first characterized the large nucleus and size of the comet, these new findings measured the thermal signal to further calculate the comet's size and the amount of dust surrounding its nucleus. And their values of the nucleus's size and dust mass are in agreement with previous ALMA observations, therefore confirm it as the largest known Oort cloud comet ever found. The discovery not only marks the first detection of molecular outgassing in this record-setting comet, but it also offers a rare glimpse into the chemistry and dynamics of objects originating from the furthest reaches of our solar system and even beyond. As the comet approaches the Sun, scientists anticipate that more and more frozen gases will begin to vaporize, revealing even more about the comet's primitive makeup and the early solar system. And these sorts of discoveries will help answer fundamental questions about where Earth and its water came from and how life-friendly environments might evolve elsewhere. This is Space Time. Still to come, NASA's Mars Perseverance rover sets a new distance record on the red planet, and the discovery that planets can trigger stellar flares. All that and more still to come on Space Time. NASA's Mars Perseverance rover set a new distance record of autonomous travel as it continues exploring the rim of the red planet's Jezero crater. The car-sized six-wheeled mobile laboratory travelled 411 metres in a single drive, guided only by its auto-nav self-driving system. It also undertook its 30th abrasion study, drilling into a Martian rock named Kenmore. It abraded a 6-centimetre wide patch, then cleared the debris with its nitrogen-powered gaseous dust removal tool. This device delivers 5 puffs of gas per operation, enabling mission managers to penetrate below the weathered exterior of the rock and examine the pristine mineral composition of the interior. Perseverance Deputy Project Scientist Ken Farley from Caltech says Kenmore was a weird, uncooperative rock that vibrated excessively and shed fragments during the grinding. Following the abrasion, Perseverance used its Watson imager to undertake a detailed observation of the rock, while at the same time its SuperCam instrument used lasers and spectrometers to examine both the abraded rock and the adjacent tailings. This revealed clay minerals with hydroxide groups bound to iron and magnesium. Previous rock samples have produced similar findings, which are typical of ancient Martian geology. But SuperCam also identified elevated levels of iron and magnesium. Subsequent analyses by the Sherlock and Pixel instruments confirmed the presence of clays and also feldspar, and it detected a magnesium hydroxide mineral for the first time. These new discoveries all help deepen science's understanding of the Martian geologic history. This is Space Time. Still to come, astronomers discover that some exoplanets on tight orbits around their host stars can actually trigger stellar flares. And later in the science report, a new study confirms that some websites are covertly using browser fingerprinting to track you and your activity across different browser sessions. All that and more still to come on Space Time. Astronomers have discovered that some exoplanets on tight orbits around their host stars can actually trigger stellar flares on those stars, resulting in a sort of planetary death wish. This is the first ever evidence of a planet triggering stellar flares. The observations, reported in the journal Nature, were made using the European Space Agency's CHEOPS, pronounced CHEOPS, spacecraft. Stellar flares are powerful blasts of energy erupting from the star's surface. The new observations found that these tremendous explosions are blasting away the orbiting planet's wispy atmosphere, causing it to steadily shrink over time. Though this was all theorized to be possible long ago, the flares seen in these observations are around 100 times more energetic than anything that was expected. Thanks to observatories like the Webb Space Telescope and NASA's Transiting Exoplanet Survey satellite tests, astronomers are already seeing interesting clues about this planet and the star it orbits. By the way, the star, named HIP 67522, is already known to be slightly larger and cooler than our Sun. But while at 4.6 billion years old, our Sun is considered to be middle-aged, HIP 67522 is still just a kid at a mere 17 million years of age. So far, astronomers have detected two planets orbiting the star. The closer of these two planets, HIP 67522b, is a so-called hot Jupiter, a gas giant taking just 7 Earth days to orbit around its host star. And because of its youth and size, scientists think that this star probably churns and spins with lots of energy. And this churning and spinning generates powerful magnetic fields. Our much older Sun has its own smaller and peaceful magnetic field. And from studying the Sun, astronomers already knew that solar flares of energy can burst from stars where magnetic field lines are twisted and suddenly released. Now this energy can take the form of anything from gentle radio waves to visible light right through to aggressive X and gamma rays. Ever since the first exoplanet, Pegasi 51, was discovered back in the 1990s, astronomers have pondered whether some of these exoplanets might be orbiting close enough to disturb their host star's magnetic fields. And if so, could that trigger a stellar flare? And a team of astronomers, led by Katerina Ilin from the Netherlands Institute of Radio Astronomy Astron, wanted to investigate this question further. Ilin says scientists hadn't seen any systems like HIP 67522 before, and when the planet was found, it was discovered that it was the youngest planet to be orbiting its host star in less than 10 Earth days. Ilin and colleagues were using tests to do a broad sweep of stars that might be flaring because of an interaction with their planets. And when TESS turned its eyes on HIP 67522, the authors thought that they may well be onto something. So to be sure, they called upon the talents of ESA's CHEOPS spacecraft. CHEOPS can target individual stars on demand with ultra-high precision. CHEOPS observed a total of 15 stellar flares, almost all coming in our direction as the planet transited in front of the star as seen from Earth. And because the flares are being seen as the planet passes in front of the star, it's highly likely that they were being triggered by the planet itself. As we mentioned earlier, a flaring star is nothing new. Our own sun regularly releases bursts of energy as solar flares, which we experience here on Earth as space weather, geomagnetic storms. This causes colourful auroral activity, usually at higher latitudes, but it can also cause damage or destruction to spacecraft, interfere with communications and navigation systems, increase the radiation dosage of people in space, and even overload terrestrial power lines, triggering blackouts. But astronomers have only ever seen this energy exchange between the star and a planet as a one-way street from the star to the planet. Knowing that HRP 67522b orbits extremely close to its host star, and assuming that the star's magnetic field is strong, the authors have deduced that the clinging planet is orbiting close enough to exert its own magnetic influence on the star. Lynn thinks that the planet gathers energy as it orbits, and then redirects that energy as waves along the star's magnetic field lines as if it's whipping on a rope. And when the wave meets the end of the magnetic field line at the star's surface, that triggers a massive flare. Now, it's the first time astronomers have seen a planet influencing its host star in such a way, and that overturns previous assumptions that stars behave quite independently. And not only is HRP 67522b triggering stellar flares, it's also triggering them in its own direction. And as a result, the planet experiences 6 times more radiation than it otherwise would. Now, unsurprisingly, being bombarded with such high-energy radiation does not bode well for the future of the planet. HRP 67522b is similar in size to Jupiter, but it only has the density of candy floss, making it one of the, well, I guess you call it, lumpiest exoplanets ever found. Now, over time, the radiation is eroding away the planet's feathery atmosphere, meaning it's losing its mass, gassing into space, much faster than what would be expected normally. The authors estimate that within the next 100 million years or so, it could go from being roughly the size of Jupiter to something much smaller, about the size of Neptune. Lynn says the planet seems to be triggering especially energetic stellar flares. The waves it sends along the star's magnetic field lines kick off flares at specific moments, but the energy of the flares is much higher than the energy of the waves. When HIP 67522b was found, it was the youngest known planet orbiting so close to its host star. Since then, astronomers have spotted a couple more similar systems. There are probably dozens more in the nearby universe. ESA's CHEOPS spacecraft was specifically developed to fill a unique role in astronomical observations. This report on its construction from ESA TV.
Since all its elements have already been proven in flight, this is a low-cost, low-risk mission, but it has high ambitions. CHEOPS is a mission with a single instrument, a powerful camera or photometer that will record the light from an exoplanet star, and its aim is to determine the nature of known exoplanets outside our solar system.
We'll be focusing on smaller planets, so Earth-sized to Neptune-sized planets, which have been found by other missions such as Kepler to be very abundant around other stars, sun-like stars, something which is not so much the case in our own solar system. So it's a big question. What are these smaller planets? What are they made of? And with CHEOPS, that is what we are aiming to discover.
To do this, CHEOPS will measure the variation in light caused by an exoplanet transiting in front of the host star to determine the planet's size. Since we already know the planet's mass from measurements made with other telescopes, scientists combine the sizes measured by CHEOPS to work out the density, which will show whether the planet is rocky or gassy. They can then learn more about its composition and also its formation and evolutionary history. CHEOPS orbits 700 kilometers above the Earth in such a way that its camera will always point towards the night side. This dusk-dawn orbit will limit any sunlight or stray light from Earth, disturbing its measurements, as it's a technical challenge to obtain precise measurements of light from stars outside our solar system.
It's not easy, and the instrument was designed to be able to perform accurately over long periods of time, and the satellite was designed around the instrument to guarantee these stable conditions. As an example, stable thermal conditions. The satellite has a sun shield protecting the instrument from the direct sun illumination, and this is very important to allow the proper thermal stabilization of the detector inside the instrument.
KAOPS, a partnership between ESA, Switzerland and member states, has a long journey of discovery ahead. This mission will not only give us key information about the nature of known small exoplanets, it could identify those with the potential to host life.
And in that report from ESA TV, we heard from ESA KAOPS project scientist Kate Isaac and ESA KAOPS project manager Nicola Rando. This is Space Time. Time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has confirmed that recent warm summers in the Antarctic have led to record lows in sea ice in the region. The findings, reported in the journal PNAS Nexus, are giving scientists a window into the future impacts of climate change. The authors looked at how recent summer sea ice extremes have impacted on ocean currents, on ice shelves, on the wildlife, and even shipping access. The authors say the research is improving science's understanding of what to expect as these extremes become more common, with sea level rise, ocean warming and wildlife loss among the likely scenarios. A new study has shown that people who receive the COVID-19 vaccines available in 2023 and 24, they targeted the XBB 1.5 Omicron variant, will end up getting increased protection from hospitalization and critical illness, well above the general immunity from previous vaccines and infections. A report Association looked at data from almost 350,000 emergency department presentations and more than 100,000 hospitalizations in the United States to find COVID-19 patients and estimate the effectiveness of the vaccines in circulation at the time. They estimate that on top of the protection against COVID-19 most people now have from prior vaccinations and getting the virus, the vaccines were 29% more effective against emergency department presentations, 30% more effective against hospitalization, and 48% more effective against critical illness, with vaccine efficiency highest from 1 week to 2 months after vaccination. A new study has confirmed that websites are covertly using browser fingerprinting to uniquely identify a web browser and then track you across your different browser sessions and sites. The findings were published as part of the proceedings of the ACM on Web Conference 2025. They show that clearing your cookies simply isn't enough to protect your privacy online. See, when you visit a website, your browser shares a surprising amount of information about you, including your personal web address, your screen resolution, your time zone and location, and your device details. When all combined, these go on to create a digital signature or fingerprint that's unique to your browser, consequently unique to you. Unlike cookies, which users can delete or block, fingerprinting is much harder to detect or prevent. Fingerprinting's always been a concern in the privacy community, but until now, there's been no hard proof that it was actually being used to track users. Most users have no idea it's happening, and even privacy-focused browsers are struggling to fully block it. Samsung will be launching its new Galaxy Z Fold and Flip 7 phones in New York at midnight tonight, Australian Eastern Standard Time. Now, although the details won't be known until then, technology editor Alex Zaharov-Royd from TechAdvice.life says the rumours are all very specific.
Samsung will hold this Unpacked event in New York, and they will be launching the latest versions of their Flip and Fold devices. Now, Samsung has already teased that these are going to be thin and light, ultra for the Fold, and so we should expect to see, like with the Samsung S25 Edge, a super thin device that will be very thin when it's open, and it will be also thin when it's closed, because you do want to have a device that isn't like two smartphones stuck together. And the questions are going to be, what is Samsung going to do to turbocharge its lead in AI over competitors like Apple? I mean, it's obviously leaning on a lot of what Google has done with Gemini Live. We're talking about the rumors saying that there'll be a 6.5-inch screen on the Fold on the outside, which is sort of previously the screens were quite narrow and people didn't like that. And then inside it should be like an 8-inch screen. I mean, none of this is confirmed officially yet, but there's obviously plenty of leaks online that potentially have come from Samsung itself. But there's all sorts of stats and specs that you can see, and whether there's going to be a price rise because of the tariffs or even a price cut because Samsung wants to capture as much of the market as possible is yet to be seen. There have been reports that Samsung will actually lower production of both the Flip and Fold this year because they just haven't sold as well as intended. But if Samsung can make a device that's thinner than ever, cost competitive, introduce more multitasking features that take advantage of the fact that you have a Flip device and a Fold device, well, all those things could very well see these devices be more popular than ever. And of course, we do have competition from people like Motorola, who have their Razr devices that are very keenly priced, cheaper than Samsung Flip. And then with the Fold, of course, we have the Fold device from Google, there's Fold from Oppo, and of course we have the triple folding device from Huawei that hasn't been launched in the West, but of course is available in China and is a technological marvel. Now, Samsung did showcase a folding screen without a crease at one of the big display events that it holds, but there's no knowledge yet as to whether that's going to be officially launched this year. But even so, even if that doesn't come this year in their commercial device, the crease should be as shallow as we've ever seen it. I did see on the Pixel Fold, for example, that the crease was a little bit deeper than you would see on a Samsung device, and that's probably because Samsung makes the screen for the Pixel Fold, and so it's saving the best technology for itself. And there's also no word as to whether Samsung is going to launch a tri-fold device this year. Probably not this year, probably next year or sometime in the future. And there's also talk as to whether Samsung will release both the FE or Fan edition for both the Flip and the Fold, which will be cheaper devices, obviously not as slim and sleek as the Fold and Flip 7, but more affordable, which would obviously boost interest and boost sales. So look, we'll have much more to talk about this when all the news is official, but you can expect that given Samsung has really stretched out with the Samsung Galaxy S25 Edge 5.8mm device, we should see that when unfolded, these devices will be even slimmer, and of course they have to then fold into a thicker device, and so it'll be interesting to see just what they were able to do, given that competition from Oppo and others has already showcased and produced very thin devices that when folded feel like traditional smartphones.
That's Alex Zaharovoid from techadvice.live, and he'll have a full detailed report on the event and the release in next week's show. And that's the show for now. Spacetime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.
This is Spacetime, Series 28, Episode 81, for broadcast on the 7th of July, 2025. Coming up on Spacetime, a new interstellar object discovered flying through our solar system. Could China beat America in bringing back samples from Mars? And the new Vera C. Rubin Observatory drops its first stunning astro images. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
Astronomers have discovered what appears to be a new interstellar object travelling through our solar system. The comet was identified by NASA's ATLAS, Asteroid Terrestrial Impact Last Alert System Survey Telescope, which is located in Chile. The object, which has been designated 3I Atlas, originated from the direction of the constellation Sagittarius. It's currently located about 670 million kilometres away. Now, since those first reports a few days ago, astronomers have looked back at observations from the same part of the sky, both using the ATLAS telescopes around the world, as well as the Zwicky transient facility at the Mount Palomar Observatory in San Diego. These so-called pre-discovery observations date back to June the 14th. Of course, numerous telescopes have reported additional observations since the comet was first reported. So what do we know? Well, we can tell you the comet poses no threat to Earth. In fact, it will pass no closer than 240 million kilometres from our planet. 3I Atlas should remain visible in ground-based telescopes through to at least September. After that, it'll pass too close to the Sun to be observed. It'll actually make perihelion, its closest approach to the Sun, around October the 30th, when it will be about 210 million kilometres away from our local star. That's roughly just inside the orbit of Mars. It's expected to reappear on the other side of the Sun by early December, allowing for renewed observations. Now, at the time of this broadcast, 3I Atlas's size and physical properties are still being investigated. Astronomers can identify an object as originating from beyond our solar system, both by its hyperbolic trajectory and its velocity. The velocity has to be greater than the minimum value needed to escape our solar system, which at Earth distance is 42 kilometers per second. 3I Atlas is currently travelling at more than 51 kilometers per second. It's only the third confirmed interstellar visitor detected passing through our solar system. Of course, the first was the asteroid Oumuamua back in 2017. It was detected when it was about 33 million kilometres away from the Earth and already heading out of the solar system. It was characterised by its unusual flat disc-like shape, reddish colour, hyperbolic trajectory through the solar system, and unexpected acceleration away from the Sun, thought to be due to the release of volatile gases. While Oumuamua's exact composition and origin remain a mystery, scientists have proposed various theories, including that it might well have been a comet with an unusual chemical makeup, or more likely a chunk that's broken off a larger object which was rich in nitrogen ices. Oumuamua came into the solar system roughly from the direction of Vega in the constellation Lyra, and its outward trajectory headed towards the constellation Pegasus. The second reported interstellar object was the comet 2I Borisov, which, unlike Oumuamua, appeared to look a lot more like a familiar natural comet, complete with a gaseous coma and a streaming tail. It was first identified in 2019. Also, unlike Oumuamua, Borisov was first spotted on its inbound journey, allowing astronomers to spend more time studying it. They discovered it had an extremely hyperbolic orbital eccentricity, passing close to the Earth on December the 28th, 2019, at a distance of about 2.8 million kilometres. Borisov entered the solar system from the direction of the constellation Cassiopeia, near the border with Perseus. Now, this direction indicates that it originated from the galactic plane, rather than the galactic halo, and it left the solar system in the direction of Telescopium. As for 3I Atlas, there's a lot more to learn, and we'll keep you informed. This is Space Time. Still to come, could China beat America in bringing the first samples back from Mars? And the new Vera C. Rubin Observatory drops its first stunning images. All that and more still to come on Space Time. There's growing speculation that China might well beat efforts by America and Europe to bring the first samples from the red planet Mars back to Earth. Now, if successful, this would rocket Beijing to the top of the latest space race, cementing the communist nation as a world leader in engineering and scientific research. Recently, Beijing officially announced its Mars Sample Return Mission project, Tianwen-3, marking a significant step forward in Chinese planetary exploration. The mission aims to bring Martian samples back to Earth, where advanced laboratory instruments can be employed to conduct comprehensive analyses, seeking to determine whether life ever existed or may still exist on the red planet. The Sample Return Mission represents the next research goal for Beijing, following its successful deployment of the Zhurong rover on Mars back in 2021 and numerous missions to the Moon, including sample returns. The thing is, right now, planet Earth is the only place we know in the entire universe that harbours life. Current research traces the origins of life back to approximately 3.8 billion years ago. That's roughly 700 million years after the formation of the Earth and the solar system. Scientists believe it was Earth's early evolution during its first 700 million years of existence which provided the setting that allowed life to develop here. However, definitive evidence is still lacking as to whether life on Earth arose solely through indigenous evolution or whether panspermia had a play. In other words, it started somewhere else and came here in meteorites. The thing is, like Earth, Mars lies within the Sun's habitable zone. That's the Goldilocks region around the star, where temperatures are not too hot, not too cold, but just right for liquid water, essential for life as we know it, to pool on a planet's surface. And of course, there's plenty of evidence now that Mars once also had a warm, wet, dense atmosphere capable of supporting life, at least early in its history. In fact, from an astrobiological perspective, the early Martian environment would have been conducive to the survival of many so-called extremophiles which are currently found on Earth. The key in China's Mars sample return mission will lie in identifying Martian materials most likely to preserve evidence of past or present Martian life. Now, to achieve this, scientists will need to conduct extensive research to work out where on Mars is the best place to go looking for life. This will include regions of Mars where liquid water was likely to be present in the planet's early history, as well as areas rich in essential metallic nutrients and sites where traces of Martian microbiological activity could potentially be preserved for billions of years. Beijing says China's Mars sample return mission will launch in 2028, and like the proposed NASA ESA mission, it'll use two separate rockets. The first will include a lander which will land on the red planet's surface to collect samples and also carry an ascent stage which will launch from the lander back up into Martian orbit, transporting the samples with it. The second rocket will be the Mars orbiter, which will wait in orbit around the red planet to receive the samples being brought back to it from the Martian surface. The lander will need to drill about 2 meters into the ground. That's a critical depth because the surface of Mars has been bombarded by radiation for billions of years. That's resulted in corrosive chemicals that could destroy any signs of past or present life. But deep below this hostile surface layer, valuable organic materials may still be preserved. Those samples will be collected, flown back up into orbit, transferred to the orbiter, and then flown back to Earth for detailed analysis. Now, if successful, China would be poised to become the first country in the world to return potentially biologically active planetary material, including potential life forms from beyond Earth. The potential risks such substances might pose to Earth life, including humans, is of course a major concern. Now, to address this problem, China plans to construct a specialized facility where Martian samples will undergo comprehensive biochemical and pathological testing under strict isolation from Earth's environment. Let's just hope the isolation facility that Beijing builds is a lot better than the Wuhan Institute of Virology. This is Space Time. Still to come, the new Vera C. Rubin Observatory drops its first stunning images, and later in the science report, the queen of flavors, vanilla, could be under threat due to climate change. All that and more still to come on Space Time. Astronomers have been astounded by the stunning first images delivered by the new Vera C. Rubin Observatory in Chile. Built by the National Science Foundation and the United States Department of Energy, the 8.4-meter optical telescope is equipped with a massive 3,200 megapixel digital camera designed to provide an ultra-wide field view of the heavens. Rubin will undertake the world's largest sky survey, repeatedly observing the entire southern hemisphere over 10 years. Known as the Legacy Survey of Space and Time, it'll provide unprecedented insights into the dynamic universe, tracking everything from asteroids and supernova explosions through to the movement of distant galaxies and the mysteries of dark matter and dark energy. To do this, Rubin will generate 20 terabytes of new data every night, an astronomical ultra-high-definition treasure trove for scientists to study. And this global scientific endeavour includes Australian astronomers and data engineers. Australian Astronomical Optics at Macquarie University has partnered with Swinburne and Curtin Universities to help process and store the data deluge that Rubin will be providing. In fact, they'll host and process more than 7 petabytes of data from the observatory every year. Head of Research Data and Software at Australian Astronomical Optics, astronomer Simon O'Toole, says it's a huge volume of material. O'Toole says that as the next generation of large telescopes and surveys comes online, the challenge will be to get all this data out to astronomers to do their analysis. And he says that requires a game-changing software platform to manage and deliver the enormous data flow.
So basically, the goal of this telescope is to map a lot of the structure and the detail of the universe, both the near universe, so within our solar system even, and the extremely distant universe. To do that, it's observing the entire southern sky in 6 colours, 6 filters every 3 nights. And then it will do that every 3 nights for 10 years. When we add all of those images together, then we get an incredibly deep image. It's like taking an incredibly long exposure with your camera. You get a lot more information, and that's why we need to understand the images and need to remove some of the artifacts and even the brightest stars to see some of the really, really faint sources and faint structures that there. But then there's also the time domain aspect as well, and that's where we'll see a lot of asteroids.
Well, you spotted a whole bunch of asteroids just in the first few hours of observation.
That's right. So I think it was around about 2,000 asteroids discovered in the first 10 hours of observation, which is amazing because that's approximately the number of asteroids that are discovered every year by all of the telescopes on Earth. So quite a remarkable feat. And this was in some ways anticipated. It's one of the reasons for doing this survey, right, is that we want to be able to observe the entire sky. And if we do that, we're going to see things that are moving at quite a fast pace. And so I can see a lot more asteroids coming because there'll be things that are further away, of course, move more slowly. So we're talking asteroids. I perhaps naively hope that if there is this Planet 9 out there, we might see that, but not going to commit to anything there.
Well, at least you know where to look for Planet 9 now. That's
Exactly.
Knowing where that gravity well is an important feature. With these asteroids, some of them are Neos. That's a bit frightening.
Yeah, it is, although I think they're pretty small. I think the Neos that are the most frightening are the ones that are large and could cause some serious chaos on Earth. And I can't remember the B612 project. I think they published, I can't remember the exact numbers, but it's around about 96% of the large sort of Earth killer asteroids are known, and then certainly we would hope that Vera Rubin might mop up the rest, find the remaining few percent of these asteroids, and so we can have a better understanding and also map out their trajectory, their path, because that's the thing when you hear a news story about asteroids that may hit Earth, it's always based on the current understanding of how it's moving through space, it's a 1 in 200 chance of colliding with Earth at some distant date 10 years in the future. They take a little bit more data, and then that goes from 1 in 200 to 1 in 2 million or something like that. And so Vera Rubin is going to be observing for 10 years at least. That's the main survey. And so I think that it will map out a lot of those sorts of near-Earth objects.
This is a very different type of observatory to other optical observatories, isn't it?
It is. And so it's an extremely large field of view. I think it's 13 square degrees per image. It's a 3.2 gigapixel camera, the largest camera ever built, and it's very, very fast. So it's an 8-meter telescope, so it's the largest imaging survey telescope ever, and it can correct for some of the Earth's atmosphere's distortion, the twinkling of the stars, and it's dedicated to this one task, to just mapping the sky every night for 10 years. And no other telescope has ever been built quite like it.
With a 10-year observation period, you're going to be able to watch the universe evolve in that time, not by much, but by something. That's got to bring the question of dark energy into it all.
Absolutely. And so because the telescope is equipped with 6 different coloured filters, they can basically determine the redshift. So effectively, it's related to the speed that a galaxy is moving away from us and the proxy for its distance. They can measure the redshift of many, many hundreds of millions and billions of galaxies. And so that will put some very tight constraints on our understanding of dark energy, and the models that are currently out there will almost certainly be put to the test. There will also be a lot of other, what we call transient phenomena, and so not just the near-Earth asteroids, but a lot of things that go bang. We'll see gravitational wave events, we'll see supernovae, I'm sure we'll be looking for the